Okay, shall we start? Welcome to our webinar on Industry Relations Day, organized by NCC Turkey and NCC Czech Republic in EuroCC project. So we will be hearing about very nice use cases and success stories by SMEs on the use of HPC, how they benefit from HPC. My name is Pınar Karagöz. I'll be moderating this webinar today. Let's start with the first talk, introduction of EuroCC-Turkey by Merve Demirtaş. Yes, floor is yours.
Thank you. Good afternoon, everybody. My name is Merve. I am working for TÜBİTAK ULAKBİM. Today, I am going to briefly talk about EuroCC-Turkey and what we have done so far during the EuroCC project. First, I would like to introduce EuroCC-Turkey structure. The lead beneficiary is the Turkish Academic Network and Information Center called TÜBİTAK ULAKBİM. This center is responsible for the management of the NCC and also coordinates the NCC activities with support of the linked third parties. TURBA is the national HPC and data infrastructure center managed by TÜBİTAK ULAKBİM and has an active role in the NCC Turkey as well as in the national HPC ecosystem. Our linked third parties are Middle East Technical University, Sabancı University, and Istanbul Technical Universities. We have also strong collaboration with other stakeholders in Turkey. TEDEP is one of them, and it funds innovative research projects for the private sector in Turkey. Additionally, we have interaction with technoparks, which are hosting many SMEs located at the linked third-party university campuses. We can say that with TEDEP and technoparks, we can reach the SMEs and industry partners easily. As I mentioned my previous slides, TURBA is the national HPC and data infrastructure center. I would like to briefly mention that is an important role in sustainability of the NCC Turkey. TÜBİTAK ULAKBİM Group started HPC studies in 2003 with more than 100 PC clusters purchased with the institutional budget. Today, TURBA resources are provided by the TURBA 2023 project, supported by the Presidency Strategy and Budget Department. It serves many researchers from different disciplines in our country with more than 25,000 processor cores, GPU accelerated computing cluster for artificial intelligence. The main goal of the TURBA to provide infrastructure services freely to the national researchers in order for them to compete with their international colleagues. Additionally, TURBA team has contributed to many national, regional, and international projects. One of them is EuroCC project, as you know that. Now I talked about NCC Turkey activities organized in the context of this project. During the EuroCC project, we carried out many training activities in a variety of fields, such as CFD, big data, parallel computing, and material science. Up to now, we have organized 15 training activities with more than 7,000 participants. We also organized additional activities like seminars, workshops, conferences, hackathons, and info days. These activities helps to increase the HPC awareness at national level. And also, we benefit the social media tools efficiently. All these events are announced through LinkedIn, Twitter, and our website. After the events completed, we share our videos on the YouTube page. In addition to training and awareness activities, we held periodically info days to inform HPC-related groups about EuroHPC calls. In these activities, we provide detailed information to the research groups about upcoming calls and details of them. Additionally, we hold one-to-one meetings with some research groups and support them for some technical details during the proposal period. With these informational days, 4 groups have been awarded supercomputing system by EuroHPC joint undertaking. We also held a day about Center of Excellences. In that day, we gave information about these centers and their advantages to collaborate with them. Parallelly, we also send mails to these centers of excellence, which we have possibly collaborate. In this context, İzmir Biomedicine and Genome Center and BioExa COE initiate a collaboration. Now, I will continue with talking about NCC Turkey's industry collaboration. Thanks to the EuroCC project, we have developed strong relation with the industry side. In order to achieve, we put a lot of efforts. First, we developed a systematic SME collaboration process. As a part of it, we organized many meetings in order to understand their needs. Through these meetings, if an SME with a problem related to HPC, HPDI, and AI, we initialized a case study, which is a small-scale project taking approximately 6 months. Maybe we can extend the time. Actually, not all problems turned into a case study. We discussed the topic and the fields by considering EuroCC project vision with our third-party university members and make an evaluation process. If the project exceeds some threshold value, then the case study will start. Additionally, to touch the industry stakeholders, we prepared forms and we share them on our website. The first form aims to construct an academic experts pool. We know that during the case studies, our industry stakeholders will have some academic needs. An expert pool has been formed with this aim, and it was distributed to our linked third-party universities. And now we have many academic mentors with different fields available for the case studies. The second form is the case study application form, and this is always open our website also. This form serves as a platform where the SMEs can easily define their problems and needs. They also write their contact info so that we can easily reach them to initialize a case study. The last form we prepared giving advices to SMEs according to their needs in HPC, HPDI, and AI. This form gives some information about EuroHPC ecosystem and encourage them to adopt HPC-related technologies in their job. With the help of all those things, we initialized 29 case studies in the field of HPC, HPDI, and AI. A lot of support has been given to the progress of these case studies. These supports are following. NCC Turkey provides sufficient amount of free computation resources during the case study. We also support them technically by infrastructure experts. In this way, we can easily move. They can easily move their jobs to the infrastructure with the help of infrastructure experts. According to field of the project, we match our SMEs with an academic expert from the pool. Academic experts give some strategic consultancy during the case study. If with all those supports and efforts, we aim to take the user group to the next level. If the SME is HPC ready before the case study, we aim to take them into HPC user group when the case study completed. Also, we encourage the SMEs to use HPC-related technologies, inform the advantages of EuroHPC ecosystem, and direct them to EuroHPC resources also. You can see the logos of the companies which we initiate case study. 20 of them of these companies are SMEs, and 8 ones are coming from the big industry. 10 of them are finalized with a remarkable result. 5 of them are turned into success story, and you can find the details on our website page. I introduced a success study, which is conducted with Erste Software. This company is a project-oriented company and provides software services in line with the needs of its clients. And the problem is actually related to big data. They deal with a large collection of data coming from a production line. And each machine on the production line produces hundreds of data points. By using this data, they try to forecast the future data points with a relative error threshold. As a solution, the NCC team helps to use GPUs on HPC environment to process such a big data. During the study, TensorFlow is used as a machine learning framework. At the end, they completed the project and they design a module application. Actually, after me, the details are explained by the company itself. Also, NCC activities from the industry side will be explained in detail by Kerem. Those are all things from our side. Thanks for your listening.
Thank you very much for the introduction. In this session, we have two presentations by these two companies. One is already mentioned, and afterwards we will have another presentation by about the maturity level, assessment of maturity level. So this will be, let me give a brief introduction or overview of the organization of the webinar as well. So in the first session, Turkish SMEs, and in the second session, we will be hearing about use cases by NCC Czech Republic. Okay, so the first company, SME, and the first use case success story on Turkish side, Erste Software. The presentation will be done by Berkay Demireller, and the company is basically working on IoT technologies, as far as I know and I understand, but the details will come from Berkay. So the floor is yours. Yes, we can see the presentation clearly, but cannot hear yet. Is it only me? Okay.
Can you hear me?
Yes, but there's a noise. There's a huge background. Yeah, it's getting better, right?
Is it okay now?
Mostly. But still, I mean, this time kind of high. I mean, the volume is high and there's still some noise. Let's check it again.
How about now?
Yeah, it's good.
It's good?
Yeah, it's okay, good for me. How about the others? I guess it's good for all of us. Okay, let's start.
Sorry about that. Hello, everyone. I am Berkay Demireller from Erste Software, and I want to share the experience we gained for this idea of using HPC clusters for predictive maintenance in manufacturing. Before touching on the main subject, I want to briefly talk about what predictive maintenance is. I want to set the floor for you. So, predictive maintenance we call a certain collection of techniques designed to monitor and act on equipment health, predictive maintenance, and its aim is to basically minimize unplanned stoppage of manufacturing operations due to failure. This aim can also be applied to other methods of maintenance as well, but so I need to distinctly describe what predictive maintenance is compared to other methods of maintenance. Firstly, if you think of a manufacturing pipeline, there will be some performance metrics that needs to be met by that pipeline. So, and those metrics almost certainly revolve around the revenue the company makes from that manufacturing pipeline. So, one of the biggest issues with these manufacturing pipelines is that there are a lot of machines involved. There are a lot of parts for those machines, and there needs to be spare parts at the ready. There needs to be a whole lot of planning for that part of the manufacturing pipeline. So one way to deal with this is to just wait for the machine to fail. So there will always be failures, unknown failures for the machine, because there are a lot of parts of the machines that cannot be controlled. There are a lot of variables for the machine's health. So it cannot always be controlled, but you want to have your machines healthy almost all the time. So there needs to be some sort of maintenance performed on them. And what the companies usually do is they do these maintenance approaches in some period of time. So they do this periodically. So for example, they do maintenance in every 6 months or every year. And this would depend on the use case, of course, and how the health deteriorates over time for the use case. So there is also a lot of planning there too. But one issue with this is that when you do periodical maintenance, you do not know what you are doing the maintenance for. So there will be a long time of stoppage of manufacturing. So because you will need to check the whole of the machine instead of just the parts that need attention from you. And
so sorry to interrupt, but just to improve the sound quality, could you try tuning it again? Maybe if you just lower.
Do you want it lower or higher?
Lower. Let's try lower because there's some background noise.
Okay, I apologize. I really don't know what that is, but
yeah, it's okay. I mean, just to make it better for both recording and for the audience. Not too bad, now? But yeah, I guess it's much better right now. Okay, thank you so much. Sorry for the interrupt.
I apologize again. Okay, so yes, and if we wanted to tell which parts we need to focus on for these machines, which ones we wanted to perform maintenance on, we need to interpret some sort of data coming from these machines, and that's where IoT comes in. So if you wanted to do predictive maintenance, if you wanted to perform predictive maintenance, you would need an investment on sensors. So there is a lot of investment here. So there needs to be a commitment from the users, end users, to properly invest in this structure. But if there is proper investment, then the benefits of predictive maintenance is very apparent to the users after some time. There will of course be some period where the users will need to accommodate themselves to using these new techniques, but after they are ready to engage in predictive maintenance, they see that this approach is probably the most cost effective for them. So how this affects the overall approach of our company is that we are involved in a project called Machine Aid, and this is a project conducted with 19 partners across 4 countries, and these countries are the Netherlands, Finland, Turkey, and South Korea. We have been working on this project since October of 2019, and we are approaching the stopping term for the project. We are still actively developing the project right now, and for IoT projects these days, the digital twins are very interesting to users. The owners of manufacturing pipelines, they always want to include some sort of digital twins to their pipelines so that they can simulate their production, maybe again for some other predictive maintenance approaches. But one of the tasks the Turkey use case focuses is, as I mentioned, predictive maintenance through machine learning and deep learning. So what we can do with machine learning and deep learning for predictive maintenance is that once we have access to data, we would then interpret those data. We would move the data through some models, and we have some machine learning models to maybe see if there are any anomalies in the data, so that those anomalies could indicate that there is something wrong going on with the machine. Or if we had access to previous failure data, how the data was trending towards a failure previously, we can see that we can compare those cycles to our new cycle to see that, okay, the data is starting to trend similarly to a previous failure. So there is a certain probability of failure now. Maybe it is best to act right now on the machine instead of waiting for the regularly scheduled maintenance. So, and of course, we can also have some output, like if the machine was approaching its end of lifetime. So if the remaining useful lifetime of the machine is approaching critical levels, we would also be able to tell these from the trends coming from the data. And the data is of course coming from the sensors connected to the machines of the owners of the manufacturing pipeline. But if you want to use machine learning and deep learning with these approaches, if you want to integrate predictive maintenance, this is one of the investments that comes in. Models and training data almost certainly will be very large. And this means that there will be a lot of needs for some resources. And usually the models work on real-time data. So there needs to be a periodical retraining approach, because since the models work on real-time data, they need to be able to learn the changes within the data. So some information may not be available to us 1 month prior, but after a month passes, there may be some new information coming from the data, and the models will need to pick that up, of course, because if not, then the whole purpose of predictive maintenance does not make sense, because we need to be able to monitor continuously. So if we were to work with large data models, of course, this means that there will be a resource-heavy training process. There will be a need for a lot of resources to have an efficient training process. But a problem is that servers affordable by the end users usually are not very powerful, and resources are mostly occupied by the service and application itself. For example, for machine aid, other than the predictive maintenance part, there are a lot of other services we provide with machine aid, such as the visualization of data or dashboarding for many other monitoring purposes other than the machine health. Or there may be some rule-based data processing, and of course the inference process of the trained models will be running on the host machine itself as well. So there's a problem here when it comes to predictive maintenance. There is a need for computing resources, but usually we do not get these by the end users. So we need to have some other solution to this. And this is where we had the idea of introducing HPC for our machine learning based manufacturing. And first I want to mention what we as Erste do. And as it was mentioned before, Erste is mostly focused on IoT projects. And there are a lot of projects Erste is involved in that includes IoT in some capacity. So we have, over our team, we have many people that are very experienced in working in IoT projects. We believe that we have the capacity to carry out many IoT projects with our company, but this means that we are used to working with streaming data, because that's the lifeblood of IoT basically. And to interpret that data, we also need to have machine learning experience, and we also gained that through our projects, through the projects we conducted. But before this EuroCC use case, we did not have any HPC experience, because we did not have to work with such amounts of data. We did not have to work with large models. So we didn't have this much resource needs for our projects. So having the access to an HPC cluster like Truba enables us to perform resource-heavy training operations. This is a very good thing. This means that we can perform our training operations very efficiently, and we believe that this experience and know-how obtained will be useful in our other projects. If you were to use an HPC cluster successfully, we believe that for our further projects too, we can integrate this HPC usage to the project, and then we can have a more efficient pipeline for our projects. So our idea for integrating HPC with our machine aid project, we had a workflow like this to define what our needs are, what needs to be done between the host machines and the HPC centers. So at the start, of course, data comes in from the factories. The machines have sensors connected to them, and these sensors send data to a certain database, a certain time series, and these data are, of course, time series. They have time series properties. So first, there needs to be a definition of what part of the data is needed. So this definition is given to us by the things we call tasks. We create tasks, and these tasks define a lot of stuff that is useful in the training process, such as the time, for example, as I said. And after the data is extracted from the database, first in the host machine, we do necessary pre-processing steps. So there may be some pre-processing need to be done before the training is done. And then we need to be able to send that data to the HPC center. because the data will probably be very large and we need to be making the data as easy to send as possible. So we do the pre-processing steps here and then we compress it. And then after that, we want to send it over with a secure shell connection. So after the data is extracted, the pre-processing is done. We send the data over to the cluster center. And there, using the data provided, the machine learning models start training according to the tasks defined at the first step. So the tasks have further instructions for the training process as well, which will be detailed in further slides. After the training process is done, then the models are organized according to their IDs, our task IDs, or what will they do. And whenever there is a need for a model from the host machine, the model is transferred back to the host machine. So we basically just use the cluster for the machine learning training process, which is the heaviest part for us. So I mentioned tasks. This is how we define tasks. We use the JSON file framework for this because they are very globally used. They are very easy to use. They are very easy to understand by people and by code as well. So whenever we define tasks, we mention these types of JSON files, and you can see that there is many keys for the task definition. For example, framework, we use TensorFlow as a machine learning framework, as it was mentioned, but we want to be able to support, for example, PyTorch as well. So there needs to be an option for that. Database would be which kind of database the user is using. So what the database is. So that needs to be defined as well, so that the data extractor can receive the data and send it to the cluster itself. And then there needs to be specifications on the job that will be done on the cluster side. So there needs to be specifications on what the partition will be used, what partition will be used, what kind of nodes will be used, how many CPUs will be used. These kinds of specifications also need to be given to us by the users when their task is created. And when we have these tasks, when they are created, we then convert these into these Slurm batch scripts, which are used in the clusters. So we can run our jobs. We can run our jobs using these scripts. So our tool converts these created task JSON files into scripts. So you can see that the specifications go here, and then you can think of this like you just start a basic training operation in some host machine, but this time the definitions given to us is given by these tasks. They are not done manually. So this is just created, and then the tool runs these scripts based on the specifications given here. So after the tool runs these scripts, we just wait for the training process to finish, and then when the training process is finished, we just, as there is a need for the model, we get the models back and we use the models on the host machine. So in this process, even though the training process is very fast, there is some offset with transferring the data needed and transferring the models forward and back between the host machine and the clusters. So that will be mentioned as well. First, for the data extraction part, as I said, it starts on the host machine because we want to be able to send as little data as possible to the cluster so that the offset isn't that large. And there are special cases to consider for this to happen. So queries on database for large data is very expensive. So we need to limit our queries as well. And if the data completely exists on the cluster, we can say that, okay, there is no need to query the database. We can just use the readily available data there. And we use that data for training. That's no problem for us. If the data didn't exist at all, then that means that, okay, we need to completely query the time range given to us. So we need a large query for that. But there are some other special cases to consider other than these two as well. So the first case would be that some part of the data that's before the end range given to us exists, but between the existing part and the starting range of the data, starting time range, there is some missing data. So we just need to query that part. And this is this occurrence is followed by our tool as well. So we query whenever there's missing parts of the data, we just query those parts. The second case would be the opposite of the first case. So from the starting range to some point in the middle, the data exists, but the endpoint does not exist. So only the missing part again. Or the third case would be the combination of these two. Basically, we would have from the left and from the right, from the starting point to some middle point, we would have missing data. And then between the endpoint and some other middle point, we would have another part of the data missing. So we need to query only those parts. We need to only pre-process that part. And then we just need to send that part to the cluster because the rest of the data exists on the cluster. So with all this in consideration, we conducted our control tests. We wanted to emphasize the effect of the size of the models as well. So we work with 4.5 megabytes of data. And with this amount of data, we had around 4 seconds of data model and script transfers. So scripts, the Slurm scripts here, they are generated in the host machine as well. These are transferred over to the cluster as well. So between these data model and script transfer, there's only 4 seconds of offset for us on this part of the testing. And as you can see, with a small model, this means that there are 260,000 parameters to train, basically. So with this amount of parameters, there isn't much difference for us between training with 8 CPUs on a host machine outside of the cluster, or training with 8 CPUs again within the cluster, or training with a GPU, with a single GPU. And also you can see that GPUs work slower for smaller models because there is a huge memory offset there. But as the model size increases, we can see that the host machine stays very slow. The host machines just cannot reach the speeds of the cluster. So we lose a lot of time per epoch if we were to continue training on our host machines provided by our end users maybe. And so as the model increases, as the data size increases, we need to move over to the cluster because as you can see there, when there are large amounts of parameters to train, the difference is very huge for us. So there will be a lot of time saved if you were to use a cluster for this purpose. And as the final example, we just didn't have the need to test it on the host machine anymore because you may have models as large as this or maybe even larger for predictive maintenance purposes, and you need to train those again also. So if you had to work with this kind of a model, for example, using a local machine, using a host machine provided, using a regular machine would just be very slow and very costly for the project itself. So this is where we see the effect of the cluster, and this is how we think we can enable our projects to better use the powers of clusters. And that will be all from my part. If you have any questions, I would be happy to answer them.
Thank you very much for the presentation.
Thank you.
Very interesting work, interesting use case. And yeah, the audience can type the questions in the Q&A part. Meanwhile, may I ask a few things? So yes. You're working on time series data.
Yes.
You already mentioned, and you keep in influx database. I mean, the time series database. This 4.5. What was the size? Gigabyte,
yes, 4.5 megabytes.
Megabytes. It was the model, right?
Oh, this is the data used. So this is the training data.
Training data. Okay, yes. This is after the pre-processing, I guess.
Yes, this is after pre-processing.
So, yes. I mean, what is the original size? From what size you reduce it to 4.5 megabyte of data?
For this particular testing, the size didn't change much because the range we were using was already cleaned for us. The data didn't need much pre-processing, so there wasn't much change between the original data and the preprocessed data, basically.
Could you, if it is not confidential, could you tell a few things about what kind of model you use, you create, what kind of neural architectures you prefer for your task?
We tested on two different architectures. One was a regular LSTM network. So we just had LSTM layers stacked on top of each other, and we used that network for one part of the testing. And another one was a variational autoencoder. So we had an autoencoder that's basically an encoder and a decoder working together. And the first part produces some statistical information coming from the data, and using that statistical information, we again decode that statistical information to reconstruct the original data. So, and again, the encoder and decoder part uses LSTM layers for this variational autoencoder as well. So we mostly used LSTM networks for these tests in some architectural shape. And
you played with the size of the architecture,
yes.
As we see on the slide, increasing parameter count and increasing number of CPUs. How much further steps you can go. And maybe I missed, what was the amount of improvement you got from this 8 CPU to 1 GPU HPC, and with the increase in parameter count? Also, if it is not confidential, it may be, I mean, this is an industrial case, but if it is possible, could you tell us? And if it is also available, maybe some general terms, in general terms, you may explain.
Of course. When the models are small, using a GPU does not make much sense here. So we can see that looking at the per epoch times here. We always looked at these with as a per epoch basis. So we averaged over some running time, and we averaged over the epochs used. So when the model gets larger, then the CPUs get slower compared to the GPUs. So as you can see in the largest example here, there is around 1,500 seconds per epoch gain for using a GPU instead of regular CPUs within the same cluster. So the model size affects this largely. What the model size and what the training data sizes affects the difference between the CPUs and the GPU usage here. We wanted to show that here.
I guess the accuracy rate also improved with this result.
We did not test the accuracy rate for this because the trained models were the same. We didn't change anything about the models between these tests.
I see.
We didn't have the need to test the accuracy of the models because the purpose of the project wasn't to see if the accuracy would increase. We just wanted to see how fast we can get with training these models.
Okay, thank you very much for the answers, for your sharing your story with us. I'm checking Q&A box. Yet there is no question, but I'd like to encourage the audience for their questions. Let's continue, but meanwhile, if the audience has questions, we can get on this use case on the Q&A. Anyway, at the end, we will have, at the very end, at the end of the second session, we will have an overview session or part. So we will be back to you, Berkay. Thanks so much.
Thank you.
Okay, let's have our second use case by Parabol, and the presentation will be done by Abdülkadir Kılavuz. Parabol is working on intelligent transportation systems, but the details will come from Abdülkadir Kılavuz. Also, I see Cevat Şener among the participants, among the panelists. Possibly we can hear more about the academic details as well as use case. So let's hear about the details on this use case The floor is yours, Abdülkadir Kılavuz. Yes, we can see the presentation perfectly. Maybe you may wanna make it full screen. Is it full screen right now? We cannot get any audio yet. Okay, it's coming. Yes, perfect. It looks very good right now.
Hello.
Hello, the sound is good also. Yeah.
Yeah, thank you. My name is Abdülkadir Kılavuz. I work as a backend developer at Parabol Yazılım. Today, I will talk about high performance data analysis experience in public transportation domain in Truba.
Just a minute. Would you like to open up the video too? If it is,
Yeah.
I mean, we can keep it like that. But if you can, yeah, the audience can see you too. Thanks so much.
Okay, you're welcome. Here is our outline. First, I will give you a brief information about collaborators and Parabol Yazılım. And then I will talk about two case studies. One is generating origin destination matrices by using smart card data for public transport, and other is finding the optimal solution to meet the demands of public transportation. And finally, I am going to talk about results and benefits. We worked on the case studies with the collaboration of TÜBİTAK ULAKBİM. Dr. Cevat Şener is from Computer Engineering Department at Middle East Technical University. And my colleague Mehmet Barutçu, who is an industrial engineer at Parabol. Parabol Yazılım has been carrying out R&D activities in the field of intelligent transportation systems since 2011. The company is also developing a public transport analysis platform called Ceremony, which uses the outputs of these case studies. Passenger card and bus location data were used. In Konya Metropolitan Municipality, spatial temporal data of 10 million rows per month is processed. Here is the problem definition for case study 1. The public transport analysis platform, Ceremony, needs to analyze the patterns of passengers. It's desired to determine the demand for public transportation in the city. In order to determine the demand, it is necessary to determine the regular journeys and multidimensional clustering. With the analysis made, the starting and ending point of the journeys were analyzed according to the regions. Here, you can see the visualization of output of our algorithms in Ceremony app. The image on the left shows us the volume of origin points at morning, and the image on the right shows us the volume of destination points at morning. The question is why we need high performance computing. Since clustering-based analysis in space, time and passenger dimensions will be performed on a data over 10 million rows. The resource requirement is high. Parallel operation is required for spatial temporal analysis. Parabol normally develops algorithms on the company's own servers or in environments created on Google Cloud platform. The suitability advantages and disadvantages of the Truba environment for such a big data problem are examined. Our first solution approach for the case study one, we first tried to apply our algorithm in Apache Beam. It is a unified programming model. It provides us the stack and stream data processing. We can run Google Dataflow, Flink, Spark, Samza by using Apache Beam model. Supported languages are Java, Python, and Go. Developing on Apache Beam by utilizing Parallel Software's previous knowledge, running the Beam model to be obtained on the Spark cluster. But there are some problems about Apache Beam. Its promises were good, but with Python, it failed to work on Spark. Open source support is very poor for Apache Beam. Running outside of Google Cloud Dataflow is practically problematic. So here come with second solution. It was decided to use Apache Spark. We have adapted the algorithms we use for Apache Beam to work on Spark with minor changes. Also, Spark needed to be ready to run on Truba. After it was installed on Truba, we experimented with Spark's RDD, data frame, and Spark SQL APIs. Our steps are, we reviewed the documentation on Truba and Slurm and did some minor tests. With the support of the Truba technical team, especially Dr. Kerem Kayabay, Spark was made available on Truba. Attempts were made, problems were fixed. We have adapted the algorithms we use for Apache Beam to work on Spark with minor changes. Here are some experiences with Spark in Truba. Anaconda is supported. Spark clusters are submitted as Slurm job. Then the job to be run is sent to the cluster with Spark submit command. Adding Spark jars is very simple. Setting the necessary parameters for Slurm and Spark is a bit of challenge at first. The waiting time in the queue can be long. A trial and error development cycle is not very easy to implement. Here is our second case study. The second stage of the public transportation decision support mechanism is to determine the optimal number of frequencies for different trips related to the same terminals. The timetable optimization algorithm in the Ceremony platform provides the optimal frequencies for public transport agencies. Algorithm tries to find the solution that best meets the OD requirements of the city with the number of vehicles and drivers available. Optimization system uses origin destination information coming from the public transport analysis platform, as well as the route and terminal information and user-specific criteria. With the analysis made, the optimal frequencies are determined. Requires all terminal-based routes in order to get optimal results. We can see the frequencies per routes. Here are our steps. We went through the documentation on Truba and did some short tests with the support of Truba technical team. Special thanks to Dr. Kerem Kayabay. The singularity image was created with required Python libraries and uploaded to Truba. We ported the algorithm onto Dask with minor modifications. This study have not finished yet. We still test our algorithm in Truba with challenging parameters. some experiences with Task. Singularity is supported, which enables portable and repeatable execution of complex application on HPC clusters. It's easy to build Singularity images with required Conda packages. Scripts are submitted as Slurm job by using Singularity images. Waiting time in the queue is short. Overall results and benefits with the collaboration of Parabol, Turba technical team and Metu, the Turba infrastructure has proven to be a suitable platform for big data algorithms. High performance data analysis enables us to run our solutions in parallel and get the results in minutes rather than hours. Outputs that will contribute to public transport service quality are obtained in a meaningful period of time. Thank you for listening. If you have any question.
Thank you very much for the presentation. 2 use cases you had. Interesting details presented. I'm checking or waiting for some questions. Yes, please, you can type on Q&A part on Zoom. So meanwhile, so you're also working on time series data, right? Could you tell us a little bit more on the nature of your data set and how large it is?
We work on about 10 million data for a month. Yes, it is a time series data. We have smart card data. It is consists of smart card ID, timestamp.
For transportation and public transportation.
Yeah, public transportation, right? Yes. And we have stop information, route information. And with our algorithms, we calculate the user's sequences by using dbScan. And then we calculate the origin destination per person, unique person.
Thank you.
That's it.
I'm also curious about the platforms and maybe the techniques you use. You mentioned about clustering dbScan. First, you started for the first case. You started with Apache Beam, and then you continued with Spark. You said it was not very satisfactory. Did you have to give up anything, or were you able to do everything that you planned at the beginning when you switched from Apache Beam to Apache Spark? Because Beam is more like batch plus streaming, I guess. I mean, they are similar, but not exactly the same. So did you face any difficulty? Did you need to make changes in your plan when you make such a switch?
Actually, I can tell a few sentences, I guess, on this question.
Okay. Welcome, Cevat Şener.
Yeah, thank you. Here, I mean, that question mostly about the first case study. Here, in fact, we had some success on Apache Beam at the beginning. I mean, without having that case study yet. We run our model on Google Cloud, okay. But we had some problems. I mean, it was not that easy to have that much resources. I mean, to have the results for for all the passenger activities we could have in a month. In fact, so we had limited that for the passengers with some, you know, commute patterns, with some high commute patterns, and we did it actually, but we needed either more time, execution time, or more resources to solve it for the other passengers as well, for at least for the other commuters. We couldn't. Then we started with the case study, and there we had problems with the beam. Actually, I mean, just on the paper, it was so good that you could port easily your Apache Beam model on Spark or some other environments of runners, but it didn't work somehow. So we just moved our model from Beam directly onto the Spark, and we did it. So at the end, in fact, everything was quite well. And we got results for the other passengers, for the other commuters as well, which took really some long time. We needed some really long time on other environments, but on Truba, we had the results in a couple of hours. For the case, the first case study, I could say that we couldn't give up any part, and we gained a lot by using Truba.
Good to hear that, and you really improved the time efficiency there. And how about the first use case and the second one? It looks like to me you wanted to try another platform. I mean, instead of this time Spark, you prefer Dask, more Python based. Maybe you switched to Python as a programming language. What was the reason? What was the motivation there in the second one?
As far as I know, I mean, it could be better answered by Abdulkadir, I guess, but from my point of view, I could say that practical reasons, mostly. We had some little difficulties when dealing with, you know, Apache Spark on HPC environment, but I mean, that was okay. Meanwhile, we have heard from, especially from Dr. Kerem, that Dask could be much easier to deal with for such kind of problems. And also that this time it was an optimization problem. And we had already some, you know, approach developed in Python towards a solution. So just we tracked. And we saw that for this type of, especially data parallel type of solutions, Dask could be little, you see, helping and much easier. But, you know, it's mostly practical. For the practical side, Abdulkadir may add much better.
Yes, anything that you want to add?
Hello everyone. Can you see?
One more.
See me?
Yes.
Yeah.
Could you introduce yourself?
Yes, of course. I am Mehmet. As Kadir mentioned at the beginning of the slide, we work as a team, and I am on the developing the optimization algorithms and deploying on the platform. And we work as a team with Cevat Hoca as well. Maybe I can inform you about the difference of the two cases and more specific results related to optimization problem. First of all, we have two different cases. In the first case, we calculate origin destination, persons origins and destinations, and we get this info. And in the second case of the problem, we use this information with the help of other constraints, so that we get optimal frequencies for each trip and on the terminal-based trips altogether, and we have the optimization problem in that. So we use origin destination information from the first case, and together with the other constraint, we get the optimization results. That's the short summary of the optimization, timetable optimization algorithm, our optimization algorithm. And we use in the optimization algorithm load data as well. Load data means in each time interval in hours, we get the passengers getting off and getting on. And the maximum point of these loads in the buses, we need to optimize those loads so that we get higher, let's say, persons, we get more happier persons in the buses, let's say. So we use this information and origin destination, with the origin destination analysis, we get optimal frequencies for each terminal-based routes, and we illustrate these results in our platform. That's the whole story of the two algorithms and our platform.
Thank you very much. It looked like they're complementary.
Yeah, we can say they are complementary. Yeah.
Okay, thanks so much for these additional information as an answer to my questions. I guess there is no further questions. Yes. But again, if the audience has questions for these use cases, please write them on Q&A part. Thanks again for the presentation. We will get back to you at the end at the discussion part of the webinar. And now the next presentation and the last one of this first session is by Kerem Kayabay, and he's going to present SME maturity assessment tool. I know a little bit, it is quite interesting, and yeah, I'm happy that I'll be hearing more about it. Yes, the floor is yours, Kerem.
Thank you. Let me share my screen first. Okay. I think you can see my slides, right?
Yes, clearly, and we can hear you clearly, very well.
Thank you. Thank you for your kind introduction. I work at TÜBİTAK Ulakbim Truba HPC Center as part of the EuroCC project. I want to share with you today a tool we can use to upskill SMEs for the emerging European supercomputer ecosystem. We did a dry run today, and it takes around 22 minutes, and we can use the remaining time for discussion. After presenting an overview of our industrial collaborations, I will briefly cover our industrial user acquisition and case study processes. Then I will share the results regarding the main benefits for the SMEs and the challenges we face. We have developed a maturity model to overcome some difficulties, so this presentation briefly covers every step of the methodology. Lastly, we will evaluate the maturity model and the effects of the EuroCC on industrial collaborations. Our NCC has created the initial structure comprising national HPC centers, academia, and partnerships to increase SME HPC capabilities toward the developing European supercomputer ecosystem, and the target competencies include high-performance computing, high-performance data analytics, and artificial intelligence. The goal is to upscale the industry as well as the academia and public sector to benefit from and contribute to the EuroHPC ecosystem. This slide is an overview of our main achievements regarding industrial collaboration experiences. We initiated 29 collaborations with the industry in HPC, big data, and artificial intelligence domains, and 21 are with SMEs. We formalized the industrial user acquisition and case study processes. A case study is typically a 6-month process where we provide the company with free resources in the HPC infrastructure for proof of concept studies. Our academic experts also offer free mentorship, and also infrastructure experts also mentorship to carry codes to the HPC system during a case study. Out of 29 case studies, 12 case studies are successfully completed, and we hope more successfully completed case studies will come until the end of the EuroCC project. And we have 7 success stories. I will distinguish between a successfully completed case study and a success story in the upcoming slides. On the right-hand side, you can see the case study distribution. 13 case studies are from the AI domain, 12 from HPC, and 4 are from big data and HPDA domain. The success stories are in manufacturing, transportation, social media, and engineering sectors. This slide gives the distribution of case studies by domain. A case study may belong to more than one domain. That's why the numbers don't add up to 29. Most of the case studies are from the AI domain, followed by HPC, and then computational fluid dynamics. And here is the distribution of case studies by sector. Most of the case studies are from the manufacturing sector, followed by social media, finance, and transportation. So how did we find the industrial users? In the beginning, it was crucial to reach industry partners who had never used HPC, but would realize cost and time benefits if they used HPC. The first channel was the existing academic industry research collaborations, since our NCC has strong academic partners as linked third parties. Our collaboration with the Technology and Innovation Funding Programs Directorate, which is part of our mother institute, allowed us to reach many industrial users. TADEP is the short name for the Technology and Innovation Funding Programs Directorate. We generated a database and search database for the potential users of HPC, and then contacted the industrial users directly. The last challenge was the technology transfer offices located in the universities. They organized project dissemination activities for the Technopolis, also located in the third-party universities. This is our industrial user acquisition process. The process starts if the company has an HPC suitable problem determined by a high-level phone call. A meeting with the NCC experts reveal if the company needs mentorship during the case study, and the NCC can provide both infrastructure and academic mentorship depending on the gaps. Experts and the company fill out the case study application form, and the form consists of the problem definition, the first suggestion, and the high-level milestones for the solution. The NCC evaluates whether the problem aligns with the goals of the EuroCC project with the third parties using a scoring system. One of the HPC providers allocates resources for the problems that receive a score above a predetermined threshold. During a 6-month case study, we request an update for the case study report in the 3rd month. If a problem prevents progress, we request an update, which we use to obtain the lessons learned to close the case study. In the end, we close the case study after receiving the final case study report. This is a successfully completed case study for us. But if the business has realized some benefits, business benefits, we also request the case study experts to fill out a success story form to disseminate the results and provide some business visibility through the NCC website. So what happens after the case study is closed? The expectation is a digitally ready industrial user becomes an HPC-ready organization, and HPC-ready organization, HPC user, and so forth. The industrial organization can request a new case study for a different proof of concept study, or they may access Truba via the direct project access mechanism. We also encourage all of our industrial users to apply for EuroHPC access. To facilitate the process in our Truba documentation, we describe the EuroHPC systems in our native Turkish language, giving technical details of the compute partitions, the storage partitions, and the resource managers. The goal is to make it easier for researchers and practitioners to select the appropriate system. I will give one example success story by DSTech. DSTech provides services solving complex engineering problems in environment, energy, and aviation sectors. The problem was the conventional water treatment systems for clean drinking water caused recirculation effects and short circuits inside the chambers. And the solution was drilling some holes in these chamber walls, which can result in an efficient contact system for effective disinfection. But this means running computationally intensive fluid dynamics simulations. And the company solved this solution by developing flow models using OpenFOAM, and the efficiency of the conventional design was improved by over 12%. The business impact was there was no need to install expensive infrastructures and incur maintenance costs. The new partnership initiated between Truba and DSTech, we can say HPC Ready organization became an HPC user organization with this case study. And for this case study, you can access the publication model files and datasets in the open archive Aperta using these links. The success story details are in this link. We observed the following main benefits of case studies for the participating organizations. The first benefit is the EuroHPC ecosystem awareness. They were able to decrease their design times and costs, but we argue the main benefits were the networking and collaboration with academia, NCC, and HPC centers, which lead to access to funds, computation, and mentorship. The companies also get increased visibility through case studies and success stories. But we continue to face many challenges. The first one is aligning the academic and industrial expectations, because academia is focused on publishing high quality research, while the industry, especially the SMEs, try to survive the competition basically. As an NCC, we have distributed partners, but we need to be lean and agile still, because the industrial users require, because since they try to survive the competition, they require rapid response from our NCC. There's a lack of awareness regarding HPC in the industrial organizations, but even if the industrial organizations are aware that they can use the HPC systems, they lack the strategy and vision. They don't know how HPC fits into their long-term business objectives. There's a lack of HPC experienced personnel, and since they lack the strategy and vision, they are not inclined to dedicate person month or move their workloads to HPC, and the HPC systems require difficult initial learning process. The National Digital Innovation Hub and Central Excellence Ecosystem for HPC is newly developing in our country. There's a concern about security and data protection regulations, which prevented us from starting some case studies. For large organizations, they don't want to wait in a job queue, so they prefer their in-house HPC systems. All of these challenges lead to the final challenge, which is initiating sustainable and mutually beneficial collaborations with the industrial organizations. So we asked ourselves as an NCC, how do we decide if we can create sustainable relationships with an organization? How to agree on expectations from each EuroCC experience level, the HPC user, HPC champion, HPC digitally ready levels? How to assess an organization's as-is situation regarding HPC capabilities? How to tailor-make our services for varying industrial needs? And how to measure the effectiveness of our industrial collaborations? So we decided to write a white paper that proposes a maturity model for SMEs. The objectives are to share our collaboration experiences from EuroCC1, but prepare for EuroCC2, building a common expectations model, to assess an SME's HPC capabilities, identifying the gaps and recommending the reasonable improvements. This maturity model builds on our SME collaborations in the first phase, interdisciplinary research expertise, EuroCC experience levels, and IT management process assessment standards. We have developed the SME HPC maturity model by following a well-defined methodology, and in the upcoming slide, I will explain each step briefly. First, starting with the determining model development approach. We have adopted the maturity model approach since such models have proved their importance in IT management. Maturity models assess an organization's as-is situation regarding IT capabilities, derive and prioritize improvement measures, and control the implementation progress. The capability maturity models provide means to improve processes to achieve higher quality across a project, a division, or an entire organization. Hundreds of organizations worldwide have utilized these models because research studies consistently show results regarding significant advantages in productivity and quality. We formed an interdisciplinary expert panel to identify the SME HPC processes. The experts work in senior and principal positions in EuroCC-Turkey, and they specialize in multiple domains. They follow all of the SME case studies from the contact phase, the acquisition phase, to the end, and also provide technical expertise when required. Since the focus is on increasing HPC capabilities, we adopted the software process improvement and capability determination model to evaluate SME HPC capabilities exhaustively. We customized the process definitions according to HPC. SPICE consists of a set of technical standards and documents, and multiple studies have customized SPICE for disciplines such as automotive, digital transformation, and data science. The capability dimension of SPICE applies to all processes across all domains. The next step is deciding the maturity levels, and we adopted the EuroCC experience level definitions. And as far as I know, the EuroCC experience level definitions first originated from NCC Czech Republic, and it's a good opportunity to talk about the maturity model in this event. We pushed the HPC innovator on top, and the difference is while the HPC champions are experts in HPC technologies, HPC innovators may contribute to the ecosystem by developing their own solutions. We recognized the need for a new level, the HPC innovator level, while linking the capability and maturity levels, which I will explain after describing the process categories and the processes. The next step is to develop the process categories and processes. Since sustainable benefits from HPC technologies depend on comprehensive strategic, executive, and technical process management, the maturity model classifies the processes under strategy management, data management, technology management, distributed and parallel application development, and supporting processes. We define each process from the SME HPC utilization perspective using the respective ISO standard, which states a process definition covers the process name, purpose, outcomes, best practices, and output work products. So in the white paper, we give details about all the processes, including the purpose, outcomes, best practices, and the output work products. Then we link the capability and maturity levels. So after iteratively developing and agreeing on the process definitions, the expert panel assigned the processes to the maturity levels. These are the maturity levels, and these are the processes assigned to each of the maturity level. Initially, the HPC innovator level did not exist. During the linkage and demo assessment stages, we needed a new maturity level to include the additional processes which are scaling out, fair data management, and innovation management. The model considers the capability levels up to level 2, since our industrial collaboration experiences show it is challenging for SMEs to allocate resources beyond this capability level regarding HPC-related processes. Then we conducted a demo assessment. The expert panel performed the demo assessment in a 3-hour-long meeting, and 2 people who helped the SME run simulations in the HPC infrastructure actually simulated the SME. Then 2 people played the assessor role, and 2 facilitated and observed the assessment process. The demo assessment revealed the unclear and ambiguous process definitions the team agreed on changing several linkages between process capability and maturity levels. The panel also suggested that a questionnaire for the updated process definitions can help with the maturity assessment. The last discussion was about how to prevent the SME participants from feeling frustrated and discouraged. And the panel considered that assessors and the SME could first determine a target level and begin the evaluation by asking questions corresponding to the lowest maturity level. The assessment would then end at the target level, or if the SME does not implement many processes at the current maturity level. This is the demonstration step. We demonstrated the maturity model in an SME that utilizes HPC for AI. We collected data by performing semi-structured interviews with the people from the case study SME, and we investigated pieces of evidence such as documents, plans, and tools. NCC experts consisting of 3 evaluators and 2 observers met with the CEO and COO for 1 hour to conduct the assessment. Following the process capability and maturity level determination, a gap analysis showed the lacking processes that prevents the SME reach the next maturity level with the prioritized and reasonable capability improvement opportunities. We prepared an assessment report, and the report comprises brief information about the maturity model, assessment results, and the prioritized improvement opportunities together with an executive summary. Most importantly, the report reveals an action plan for reasonable improvement opportunities, the business benefits that would incentivize the SME to reach the next level, and how the EuroCC-Turkey can help bridge the gaps for the SME. Lastly, I want to evaluate the results with you. The HPC SME HPC maturity model is not a silver bullet. We know that because additional measures are necessary. For example, an SME cannot readily scale its application from national HPC systems to a European level supercomputer, select the best system, and adapt application codes between systems. But we believe it's good for building a common expectations model around the HPC experience levels, assessment and prioritization of gaps regarding HPC capabilities, driving an action plan, and develop tailored services to bridge the gaps. NCCs can measure the effectiveness of their SME services, and EuroHPC can devise mechanisms on the European supercomputers to incentivize becoming an SME HPC innovator based on transparent and concrete objective assessments. Lastly, the model can also assist SMEs participating in the EuroHPC ecosystem in other countries. We provide the methodology and the detailed process definitions for developing the maturity model. Therefore, other NCCs can tailor-make the model according to their circumstances or use the model as is. Similarly, the EuroCC can use the model as is or apply minor modifications to create one common expectations model across the NCCs. Here's the evaluation of the effect of the EuroCC project on our industrial collaborations. The EuroCC project helped us enhance the limited industrial collaborations on the infrastructure level. We prioritized and initiated new academia industrial collaborations. We also established new collaborations with the other NCCs and the European projects. We collaborate with the NCC Czech Republic in training and workshop-based events, such as this one. Mind for Machines is led by Istanbul Chamber of Industry, and it creates a funding mechanism for technology provider SMEs. The collaboration with the Mind for Machines aims to support the HPC infrastructure adoption in manufacturing companies toward more sustainable and resource-efficient manufacturing. The Sparsity Project Consortium includes Koç and Sabancı universities, and this collaboration can help maximize sparse computation performance and energy efficiency for SME case studies in the upcoming phase of the project, which brings me to our plans to strengthen the industrial collaborations in EuroCC2. We will continue developing the maturity model using feedback. We may extend the model to SME assess the HPC capabilities in large organizations, the public sector, and academia, but we will first wait for the feedback for the SME HPC maturity model if this maturity model is successful. We plan to provide tailored and measured services using maturity assessments and involve academia in all aspects, but in a more structured fashion. We may define additional criteria to start case studies, which may include the maturity assessments together with the technology readiness levels. And we plan to collaborate with European digital innovation hubs for dispersing our services to strategic cities of Turkey, but we will see how the digital innovation hubs will develop in our country. Which brings me to the end of my presentation. Thank you.
Thank you very much for the presentation. An interesting work on the assessment tool, and also a nice overview of what has been done and what is planned for the next phase of the process or the project. I'm curious about, especially this assessment model. You wanna continue? Possibly it will evolve, and maybe the maturity assessment will be more mature. You applied it on one case study so far.
Actually, two case studies, but the white paper only presents one of them.
How is the plan? I guess you want to extend it to other case studies, maybe possibly on international level. Any planning for on that side?
Yes, we have some plans. Up until now, we have applied the maturity model to two SMEs. They both work in AI domains on the HPC infrastructure. We are planning to use the maturity tool with Parabol, which works with in the HPDA domain with the HPC infrastructure, and we also want to generalize to the HPC case studies, and then basically try to build services, tailored services, considering the gaps in the SMEs. And we want to use the assessments to see if really, if the case studies really help the participating organizations. And in the midterm, if EuroHPC really incentivizes organizations, for example, we may we may support the case studies, SME case studies with more resources, the HPC champions with more resources on the national level. But if EuroHPC incentivizes the SME HPC innovators on the European supercomputers, we have much better chances for explaining the business benefits for the participating SME organizations. So that's our plan.
Thank you very much. This now you have a white paper, and I guess it is publicly available, right, for the other NCCs?
It will be publicly available soon.
Okay. Maybe you may go towards an academic paper too, because there are management or technical management oriented,
yes.
academic
that's our plan.
publications.
Okay. After we get to 3 case studies, that's our plan.
Okay, best of luck on that direction too.
Thank you.
Okay, thanks so much for the presentation and the answers. I guess, that's all about the questions. Unfortunately, the Q&A box is again empty. This takes us to the end of the first session. Although it is slightly an early break, I guess we can have our coffee break. Then shall we meet at original time 4 p.m. or 2 p.m. for Czech Republic, 4 p.m. for Turkey? Is it okay for all?
Yes.
Okay.
Thank you.
Okay, then let's have our coffee break, and we're gonna meet at 2 p.m. CET or Czech at 4 p.m. Turkish time. Okay, see you in half an hour. Welcome back to the second session of Industry Relations Day webinar organized by EuroCC, NCC of Turkey and NCC of Czech Republic. In the second session, we will be hearing more about the NCC Czech Republic side and use cases there. I'll be moderating this session too. We'll be together. My name is Pınar Karagöz and I'm a faculty member in Computer Engineering Department, Middle East Technical University, and also a member of EuroCC-Turkey team. So the first presentation is by Tomasz Karasek. I hope I said it correctly. And he's going to present, introduce NCC Czech Republic. Yes, we can start, Tomasz, if you're ready.
I'm ready, thank you very much. Just one check. Do you see my full screen or the presenter's mode?
No, full screen, it is good.
Full screen, perfect, thank you very much.
But we cannot see you. I mean, we can hear you perfectly. If you prefer to turn your video on, we can see you, but otherwise it's okay. Yeah, as well. It's up to you.
Because of the bandwidth of my Wi-Fi, I will switch my video off.
Okay.
I apologize for that. Okay, so
no problem.
For the kind invitation to your workshop. I will have today 3 talks, and my colleague Michal Kravchenko will have 1 talk, and we will present you what we are doing within our center here in Czech Republic. So one of our activities among many is activities within the NCC of the Czech Republic. You already heard about the NCCs a lot. So basically the Czech Republic is one of the 33 countries which is participating in EuroHPC joint undertaking, and it's hosting one of the national competence centers. In our case, the mission is very similar to the mission of all the NCCs around Europe. So basically to be a hub for the HPC, HPDA, and AI for all the stakeholders, focusing on the industry, especially SMEs, but not omitting the academia and the public institutions. Academia, for a reason that in Czech Republic, the HPC is primarily used by the academic users, and our infrastructure is operated from the national funds, and it's basically providing access to the researchers from the Czech Republic for the free. And the public institutions, basically what we are trying to get is to get them on board and raise awareness among those public institutions that HPC exists and could be used in their daily lives. For the public institutions, for example, we also count the hospitals because they are not research institutions, but they, in our definition, falls inside the public institutions. And I am mentioning them because I will show one of the success stories we've done with the local hospital. To inform our stakeholders in the Czech Republic, we created the NCC portal, which is a one-stop shop for those who are interested in what we are doing. And we also inform them through social media. We have the newsletter in the Czech, and we are informing them what happening in Czech Republic, what happening in the Europe regarding to HPC and HPDA and AI. As all NCCs within the EuroCC project, we have several how to call it, tasks which are carried out by all the NCCs. One of them is the competence mapping. So basically, at the beginning of the project, we used our user base, which means our users of the HPC infrastructure, and we based the competence mapping based on the data we have from all the open calls between 2016 and 2019. And we use the statistics to know who are our users and to which group we should focus. As you can see, the majority is the research institutions, as I mentioned, because we primarily serve the researchers in the academia in the Czech Republic, but 7% of our users are companies, which I think it's not bad. If you look who basically, I mean, which scientific field is most using our resources, it's material science and biosciences, and they make almost more than 80% of our resources is used by those two fields. The material science, it's obvious. These are the non-materials, chemical calculations, etc., etc. At the beginning, we start to develop the questionnaire. We prepared the survey, which we basically sent out to our stakeholders, and we received their input. And now we analyze it, and we will, at the end of the project, we will publish what we learned from our users. And this survey was structured in some way that in such a way that different target groups went through the different branch of this survey, because we knew that we cannot ask the users from the academia the same questions as the users from the industry, because there is no size of the company, whether it's SME or small. This one makes no sense in case of the academia and vice versa. And also, it doesn't make sense to ask the end users who are using codes to do their computation. In previous talks, you saw, for example, OpenFOAM, which is one of the codes which is used on our infrastructure as well. So it makes no sense to ask the people who are using the OpenFOAM the questions, how do you parallelize your code? Are you using the MPI or OpenMP, etc., because these guys usually they don't have this knowledge. They don't care. They use the code. They are not developers. And of course, we ask them about the competencies and about their gaps. So we are analyzing this survey, and we will publish our findings in the last delivery of the EuroCC project. The second task, which is common for all the NCCs, is the training and skills development. In our NCC, we focused on several things. One of them was the survey for the training. We created the survey just for the training because we didn't want to overflood people with a survey which will take 40 minutes to fill in. So we split it, and we had a separate survey just for the training. The second activity was the new training. So we developed several new courses based on our users' needs. We created several on-demand trainings. So a certain group of the researchers came to us, and they said, okay, the training you provide is too generic for us. We would need something more customized to our needs. So we did that. And we also are extending the pool of our trainers. So we have this train-the-trainer scheme where we basically let our staff to pick up the new competencies and new knowledge, so they are able to provide those training in the future. So just a short glimpse what we learned from our training survey. Again, the same story. Academia is the majority of our users, and we basically ask them many questions. We are also interested how long the training should take, because that's important for us, whether it should be 1 day, 2 days, or even longer. And you can see that the most of the people are preferring 1 or 2 days training. If it's longer, it's too complicated for them, because they have to come to Ostrava, stay here for several days, which is not preferable. But this one is mainly about the face-to-face trainings. The hybrid could give us the different picture. Again, it could be seen that which format they would prefer. So lecture covering the broad range with hands-on or without the hands-on, etc. So our users are preferring the hands-on session, and we are going to take this into consideration when we will develop the new courses. We also learned what is the gaps, what they are missing the most. So we ask not only about the areas like performance analysis, profiling, parallel programming, GPU, of course, AI, neural networks, visualization. These topics were received, but we also asked them about the particular applications and tools. So as you can see, the TensorFlow and the PyTorch, which are the frameworks for the neural networks or for the AI, are in the high demand. The second one is the Blender, which is the code for or framework for the visualization, and the ParaView scientific visualization. And we are quite surprised that the ANSYS commercial code for the multiphysics simulation is also in high demand. And programming languages are Python and C++. These are the languages that our users would prefer to use and to learn about this a little bit more. Another activities which we are pursuing within the EuroCC project is collaboration with the industry, because we are trying to get the companies, especially SMEs, on board to take the HPC technologies and use them into their daily life. And thanks to the EuroCC project, we could switch from the, let's say, passive approach where we get our new customers or new partners from the industry through our personal networks, to more active approach, where our colleague, who is the part of the business development team, is actively identifying the SMEs, contacting them, and trying to get them on board. When he is getting the company who is interested to know more about the competencies, our technical colleagues are taking over and discussing with the company what could be done, and then we choose which mode of the collaboration is the best one, whether we will do the proof of concept for those companies who are new in this area, or even for the problems we know that it should be possible to solve by the HPC, but we have to prove it to the company through the high-level support if the company needs to help with their code. And we also do the funding, identification of the funding opportunities which I will mention later on, because one of our collaboration with the company started as a proof of the concept, and then we applied for the national funds, and now we are basically collaborating with this company to resolve the problem. I will be talking about this this case in a short while, and Michal Kravchenko will elaborate on this one, because he has a very nice technical presentation what we are doing with this company. So let me skip to several success stories. The first one is with the local teaching hospital, which we have just across the street from our university campus. And with this company, we are working on the segmentation of the CT images and creation of the 3D models. This job is quite time consuming, and it needs a lot of effort from the radiology specialist. So we are looking into ways how to improve it. In several years ago, we started with algorithms like a k-means, etc. But as the state of the art is evolving and it's getting better and better, now the neural networks or AI could be used for this task. So basically, with our colleagues from the teaching hospital, we did this proof of concept where we use the Clara, which is system from NVIDIA, and we installed their backend on our infrastructure and front end at the hospital. And basically, the doctors use this front end to load the CT images, and then they send it to HPC infrastructure. There, the identification of the given organ, right now we are working on the liver, is done by the trained neural network, and the results are sent to the hospital, and the doctor or radiologist could inspect the results, correct them, and send it, use it for their purposes, and send the corrected results to us for the later retraining of the neural network. So within this proof of concept, we deployed the system. We basically teach or give the training to the medical doctors how to use it, and right now they are using it for segmentation of the organs. And in the future, we would like to enhance the neural network models, so in the future the correction from the doctor won't be necessary. So there are some pictures how from the CT scan of the liver you will get the 3D model of the liver for the doctors. The second example is the one I already mentioned, is the CFD simulation of the catalyst reaction. And basically the company contacted us with the request that for the purposes of creating the proposal for the customers, they will need the tool which will allow them very quickly and very efficiently do the first design of their equipment for the catalyst reaction. On the right side, you can see these are the catalysts which are put into the exhaust system of the power plant, and because they are building in their solution to the existing system, they are very limited by the space, and they are very limited by the options how to do this. And before they are selected to basically implement their solution, they have to be able to provide the quotation for the companies and for the customers, and for that they need the very quick tool. So we were analyzing this problem. We designed the way how it could be done, and within the EuroCC project, we basically used the CFD simulation to test whether the CFD simulations with the chemical reactions will be able to predict the catalyst reaction. We succeeded with this one, and we were able to provide such a calculation, so we could proceed to the next step, which was creating the tool for a very quick design of this system. But my colleague Michal Kravchenko will be talking about this one in a short while. Another example is from the company which is developing such exoskeletons which are used for the people with the injuries, and this company is a designing company. They are using the basic simulation tools, and they approach us to consult them on the ways how they use this simulation tool to come out with the results. So basically, we guided them through all the process. We showed them how this must be done so the results are reliable, and we told them that we basically changed their way of using this software tool, because for some reasons, for some limitations, they were unable to simulate the whole system. They had to cut it in parts and simulate it separately. But we showed them that this is no way how to go, because the results are not very reliable. Another example is with the company Advanced Engineering, which is a company providing the consultation services and the software alter to their customers. And for one of their customers, they needed to do the scalability test or benchmarking of our infrastructure using the discrete element model code. So basically, together with them, we provided the access to the HPC infrastructure, and they benchmark their codes. So in the future, their customer will know that how long it will take to calculate their specific design, because if you are in this area of numerical modeling and simulations, you know that until you run a few tests on your geometry or on your specific problem, you will never know how long it will take, because each problem is different, and there are no even benchmark which are close. So basically, this information is very important for those companies. Another proof of the concept, just the simple mixing of fluids. There's a company which has this equipment or this facility for the mixing of the fluids, and this fluid is mixed by the air, but because of the design, they have some problems. So we were showing them that using the CFD, in this case OpenFOAM, could give them the inside view of what's happening there, and even the optimization could be done. So we are discussing right now with this company how to proceed from this simple example to the simulation of their actual needs. As you can see, you can even put another liquid into into this basin, and how the mixing will look like. Another example is CFD simulation of the valve closing. This is the company who is using the CFD simulation to design their equipment, but they approach us to see whether we could help them, because they do the simplified solutions because of the restriction of their hardware. So first of all, we studied several methods how to solve this problem, because in the CFD you have 4 methods, as you can see, and we compared the results from all those 4 methods, and we told them, okay, this method gives this kind of results, this method gives this kind of results, and you can compare it, and you can also compare how time-consuming those methods are, because one or two, there are different requirements for the hardware and how long it will take. So basically, we provided this information for the company, and it gives them the idea how to proceed and what is the difference between those methodologies. And that concludes my short introduction of the NCC Czech Republic and our activities.
Thank you very much for this introduction, Tomasz. Very interesting use cases for medical and several CFD simulation studies. Shall we continue with the first use case? I guess that one will be presented by Michal Kravchenko. Michal, could you share?
Yes, hello.
Your presentation? Hello.
Hello.
Yes, we can hear you and we can see you very well.
I think I
oh, yeah. Okay.
Can you see my screen?
Yeah, that's good.
Okay, I have the same connection as my boss, so if I stutter or something, then let me know and I will disable the video.
Okay. So far, so good.
Yeah. So my name is Michal Kravchenko, and I will talk about our approach to solving the catalytic modeling of reactions in complex structures, introduced by Tomáš Krásik. This slide depicts the structure which represents a complex facility used in practice, and this slide was prepared by my colleague, and he included some joke about height here, so I apologize because I don't remember that joke. I will skip to the next slide, which describes the facility more clearly. I think it was designed to be intimidating to listeners. So it has basically 3 parts. There is a part which serves as a feeder of fuel to a combustion chamber, which then produces waste, which is transferred in the inlet exhaustion pipe, and some waste is gathered, and there needs to be some gases eliminated, and chemical reactions need to happen that purify the output, so we can satisfy the demands by the European Union and Mother Nature. So our task was to model, instead of using very expensive computational fluid dynamics used to model these things, we were tasked to find a surrogate model which is very cheap, which has very nice analytical expression if it exists. And something beeped. I'm not sure what it was. And find out if we are able to do that and how precise can we get. So this is a basic facility which serves as an illustration. And in order to find out if we are able to model something like this, my colleagues prepared several example parts of the facility, right? We are talking about this red part, which is served to gather some waste and output the gases which are then homogenized and purified by the catalytic reactions. So there are several types of exhaustion pipes, and we decided to focus our attention in the initial stage to the A5 geometry, right? So there is some inlet which accepts the gases and the heat, and an outlet which lets everything out into the open. And in the outlet pipe, there are placed the catalytic devices and homogenizers which are required to smooth everything out. I will explain more in detail in a bit. So in this variant, there are certain parameters of the experiment which guide the computational fluid dynamic. And what we are interested in, based on the velocity and input profile of the gases, we are interested in analyzing how the outlet behaves at certain level. So what we did, we modeled something using CFD, and we picked several levels in the outlet and measured how the gases behave there. And from that, we determined one scalar value, which is called uniformity of velocity, uniformity index. And that's what we wanted to model by our surrogate models, because we want to predict this uniformity, which lets us estimate where we should put homogenizing filters to smooth out the profile of the gases, where we should put the catalytic devices, and instead of using expensive CFD. So this is the basic explanation of how we designed our experiments. So for this particular example, there are parameters like velocity on the inlet and dimensions of the profiles of the inlet and the outlet. We were controlling for the angle between inlet and the outlet and certain positional variances in the outlet. So the red part represents the homogenizing filter, and there were several predetermined levels in which we measured the profiles of the gases on the output and their uniformities. So in our case, given these parameters x, y, u, v, w, alpha, velocity, and the height in the outlet, we would like to predict the uniformity at that height given these parameters. That was my goal. And you can see it here. This is just a static visualization. So there is the inlet, there is some gases going in, and in the outlet, the profile is non-uniform. It has certain rules, but it changes depending on the height. And instead of modeling this profile, we are interested only in one number given by this complex integral, which takes the profile in one given level, gives us one number representing the uniformity of that level. And that's what we want to learn or teach our surrogate model. In order to traverse all possible settings for this, we use the Dakota software for designing our experiments. So in here, you can see the boundary values for each parameter, and Dakota software automatically explore the space of parameters in order to design parameter files which we input into OpenFOAM software, which calculated expensive computational fluid dynamics. It measured the profiles at predetermined levels in the outlets, and then analyzed these profiles to output the uniformity indexes. So what we got was some set of results, many results for one geometric configuration, and then we wanted to see if we are able to find a connection between the inputs and the outputs. Our goal was to find a simple analytical formula. So we first assumed that we can use symbolic regression, for which we use the Python framework. But unfortunately, this problem turned out to be quite complicated for this task, or we were not able to understand how to use it efficiently. The results produced were not accurate and used only few of the input variables. And my personal thought is that we would need to devote exponentially more time to find acceptable solutions, but it's possible that we missed something, and we should have seeken out some consultation with an expert. So given this result, not very good for us, we decided to try deep neural networks and using TensorFlow with Keras, which is sufficient for us because if the networks are not deep enough, they can be represented simply by analytical formulas. For example, a combination of hyperbolic tangent functions, and our partner in the industry could be satisfied with this. They could use it without any installation of software. They could just input that formula wherever they want to and use it as it is. And this was successful. This is just analysis of the parameters on the outputs at the different levels. And we can see that at each level, the histogram of values is similar. So that told us that this problem should be solvable by networks with low complexity. We can see that when we increase number of experiments, the histograms converge to something which is nice. And now it's almost the end of the presentation. These are the practical results. We completed, or we did work in two phases. In the first phase, we used 80% of the experiments as training data and the remaining 20 as testing data. And here you can see results for two different architectures, one using 32 hidden neurons and the other just 8. And you can see that for 8 neurons, the error distribution is more flat, which is to be expected. But both the training and testing data follow the same curve, which is good for us because it tells us that the way in which we worked with the data is correct, that we are not overfitting, we are not over-representing or under-representing. And another nice thing is that when we increase the number of neurons, the error distribution became more towards 0. So I will show you now something else. Right, so this is the summary. Given these input parameters, we obtained 14 measurements in the outlet. So for one experiment, one geometry, we obtained 14 entries in the training or testing data, depending on the height. And this we used to try to find analytical formula in this with this prescription. So we used just one hidden layer in the neural network using hyperbolic tangents as the activation functions, and we tested it with very low number of hidden neurons in each layer, because we wanted to find the simplest representation of the dependencies between the outputs and the inputs. And I will show you now just five images, I think. This is the error distribution for the simplest possible architecture with only one hidden neuron. And we can see that for 80% of the training data and testing data, the error was at most 5%. So this is the cumulative distribution of error, and this is the practical. We can see that, for example, 2% of all data points had error of 1% just in this architecture. When we increase the number of neurons to 2, we can see that the error distribution becomes much nicer. We can see now that around 95% of the data points had error at most 5%, which is good. And for 4 hidden neurons, almost all the data points had error at most 5%. For 8, I mean, this doesn't change much, but we can see a trend which suggested that we had the correct implementation. It behaved like it was supposed to, and it was optimistic to have this proof of concept. Now I will show you just final set of images. This represents the levels of uniformity in the outlet. So on the x-axis, we have distance from bottom when we and the blue points represent the uniformity indices based on the height, based on the distance from bottom of the outlet. Right? Y is the uniformity index between 0 and 1, and the red line represents what the model thinks it should be, the uniformity index. So for one hidden neuron, it loosely follows the trend, which is to be expected, but it's not far off. For 2, the beginning of the prediction seems to fit, but the middle is quite wonky. For 4, this was decided to be a sufficient model by our partner. It very closely resembles the relations. For 8, it's even better, and for 16, it's almost without error on this particular example. So we are quite happy with this result. Our partner is happy, and we can continue on developing more general models, because so far this is for one particular geometry. And sorry, that's all.
Thanks so much. Quite interesting. Mechanical design. It involves a design, mechanical design, geometry, and then CFD, and then finally a machine learning combination of many components in the work. Of course, the CFD and design part were quite new for me. I'm not expert on that. Mostly, I mean, machine learning is closer to me, but on the overall, it's really an interesting work. Yeah, the audience can type the questions in Q&A. But meanwhile, may I ask, yeah, how was the maturity level improvement of the user of the company? So how much they learned and how mature they become from beginning, at the beginning and at the end. So any observation on that?
I'm not sure I understand the question, but I didn't.
I did, Michal. Can I answer it?
No.
This company is using the CFD simulation performing on their designs. When they do the actual design, they use the CFD. They are familiar with the CFD. but they weren't familiar with the surrogate model approach, and of course, and not the AI or neural network. So basically, this is the next level for them. They were looking for simplified formula which they can use for their own software. So basically, for them, it's quite a huge improvement in their operations, because now they will be able to implement this surrogate model in the more complex software they use for this design of these facilities.
Quite good improvement. Thanks for the answer. Yeah, it looks like a very effective project, effective use case.
Yeah, it is because it helps them, because it for their needs, the CFD simulation is not necessary to do it, and they cannot afford to do it at the time when they have to prepare the quotation. Of course, in the design cycle, they can do the simulations and confirm it, but during the quotation, they need the quick answer, and the surrogate model is one way to go. And when we were thinking, because the surrogate model, it's all about the interpolation from the known results. And when we were analyzing the problem, we said, okay, the symbolic regression, or in our case, neural networks, is the way to go, because if you have six parameters, your response surface is not that trivial. It's quite complex. So the neural network seems to be the way to go.
Thank you very much for the additional explanations. And any other questions from the audience? If not, then we can continue with the next use case. I think Tomasz will be hearing this from you again. By the way, your title is seen here. I forgot to mention that you're part of NCC and also in the IT4I National Computing Center.
Yes, we're wearing many hats. This is another example. This is the project we finished a couple of years back, but I think it's a good example how to increase the maturity or digitalization of the company to the next level using the numerical modeling and simulation and the HPC. So the motivation for this project was the company, the Borket, which is designing and manufacturing those passenger seats for the trains. They were trying to penetrate the British and Canadian market, and in the UK and in the Canada, they require their passenger seats to be tested by the crash tests, the same as you perform for the cars. In this case, it's for the seats. And if you would like to basically sell your products on this market, your seats must be certified. And these tests are very expensive, and if you do it by the old-fashioned approach, design, build a prototype, smash it against the wall, destroy it, it's costly, and you don't get that much information. And in this case, basically you are trying to develop the seat which is strong enough to withstand the impact and not to break or disintegrate. But on the other hand, it must be flexible enough So the dummy representing the passenger will survive this impact. And from the designing point of view, these two requirements are canceling each other, because if you want to have the seat which is structurally stable or structurally robust, the figurine will, let's say, die or will be smashed, and vice versa. If your seat in front of the figure is flexible enough, it won't survive the impact. So when they approach us, we basically told them, look, the only way how to do it is to use the numerical modeling and simulation, finite element models, and do the impact test in the computer. And when we develop this model, you will be able to use it for the future design. This project was 2.5 years, if I'm not wrong, and we spent 2 years developing the methodology and testing everything in the computer, but I will be talking about this later. So basically, the classical design cycle is designer will draw the drawings, the product is manufactured, and it goes to the customer. In the UK or in the Britain, there is this requirement for the passenger safety check. So the prototype must go to the certified laboratory. It's smashed against the wall, and it either pass or no pass. There are no other options. And if you don't pass this test, you have to go back to the drawing without any knowledge what went wrong. You will get the video, you will get the data from the sensors, but it won't tell you too much, so you cannot learn what you should change in your design. So basically, we changed this approach to one that we use the supercomputer, we use the numerical modeling and simulation. We performed the virtual crash test, and only when this crash test, only when this virtual model passed the crash test, the company built the prototype, sent it to the lab, and they passed. But we did many cycles with the designers because the design didn't pass. So we said, okay, these are the things you should focus on. And when they did the changes, we run the simulation again, and within this cycle, we basically together come out with the design, which later on passed the physical testing. So our approach was to use the numerical modeling and simulation, in this case, finite element method, since this is a very fast, it happens very fast. We use the explicit solver, and we had to build the very detailed model of the passenger seats, and we had to include the dummies. There were several setups of the dummies. The most complex ones you can see on the picture on the right, where you have 3 rows of the seats, and you have 3 dummies, different sizes, different masses, and basically that was the setup. But to get there, it was the really long journey, but we learned a lot. The first of all, what this simulation helped us to identify where the problems. So you couldn't see this one on the video, or getting this information from the sensors. But what we find out in the simulation is that the passenger seat basically didn't survive the impact, because there was tearing of the lower structure of the seat from the floor. So that was one finding that we passed to the company, telling them, look, you have to focus on this area, on this specific area, because this is the reason why your test failed. And from there, when this problem was resolved, we were continuing to other areas where we identified the problems, and we were solving it together with the designers. For example, next problem was the welds. We identified that the structure is not properly welded, and in certain areas this could lead to the disintegration of the passenger seat. So we proposed the possible solutions, and we checked the simulation results, and we said, okay, this solution might be suitable. So this is another way how this could help designer. This is, let's say, what if analysis. What happens if we apply those measures or we use this solution? How it will affect the results? And it's much easier to do in the computer than, you know, build several prototypes, destroy them, and see what's going on. This complexity of the problem basically lead us to the things which those people who are doing those calculations, they usually don't do. If you do the welded structures, you estimate the welds. You don't model them or you don't simulate them. You just estimated them. But we find out that we cannot do that, because if we want to pass the test, we must know how those welds are behaving. And we said, okay, we need the test results, because we need really precise behavior of those welds. And we even realized that the classical welds, which you can see on the left side, or classical specimens, won't work for us. So on the right side, you can see that we even designed our own specimens to test the welds in such a way which is very similar to the loading they will experience in the crash test. So we even went this extra mile to increase the fidelity of our model, but by increasing the fidelity by adding another information about the welds. So as you can see, we did the several tests, and we were able to model all the welds on this seat quite precisely. Another thing which we realized after the testing is that because there are those dummies, it's very important to know how this dummy is moving during this crash test. And it's very important to know what is the friction coefficient between the shoe and the floor. Because if we estimated it wrong, the dummy is behaving in the virtual model totally differently than in the real life. And then we realized then we are not able to do our simulations with the static friction only. We have to use the kinematic friction, which you can't find anywhere. So we had to measure it. We have to take the equation from the textbooks, but we had to measure the coefficients to be able to establish the friction coefficient, because it really changed the results, how the dummy behaved. And since we needed those correct values, we had to measure it. So when we applied all the knowledge we gained in those 2 years, we were ready for testing. So based on design which we help to improve. The company build the prototype, and they send it to the testing laboratory. And here you can see the visualization from the movies comparing to our calculations. This one is a nice catching for the eye, but these are the results which we compare, and these are the results from the sensors. And on the left side, you can see the acceleration of the sensor which is placed into the dummy's head, and on the right side there is a force measurement in the femur, which is the leg of the dummy. And as you can see, that these curves are really close together. So basically, the blue one is the one which we get from the simulation, and the red one is from the real testing. As you can see, it's really close, almost identical. So this means that our model and our effort is well paid, because we were able to predict the real behavior, not only of the passenger seat but also of the dummy, which is really difficult without all those measures we had to take. So what are the benefits of the company for the company? They basically shortened the design cycle. They could skip this very expensive building the prototype, waiting for the opportunity to measure it, getting smashed against the wall, not passing through the test, and have to rebuild the prototype. Of course, there is a saving of the costs associated with that, and because they were able to use the HPC, they could reduce the computational time. This could be done on the workstation as well, but it would take much longer to get the results. Using the HPC infrastructure, it's much faster, and you can obtain your results much faster. Another benefits are basically they can do the virtual testing of the design changes. So in the future, if they do the design changes of the lower structure of the seat, or they change the seat itself, they can test it, and they can do it much faster. On the right side, you have totally different design. Is the cantilever beam which is supporting the seats, and they were testing this one as well. And thanks to those 2 years we spent on the methodology, this one was done in probably 1 month, just to build a model, do the virtual testing, changing the design until it passes the virtual test, and then sending to the laboratory to pass the test. So that's really speed up the whole process. And thanks to the virtual model, they could do the parametric study. This one is parametric study for the first class passenger seats, which are like in the airplanes that you have this folding table. And there is another very cruel test this must pass, because you have the dummy, you have the table which is open, and dummy even have to survive the impact to the open table. And on the top of that, because this company is selling their products, the seats, to the manufacturers of the cars, so it's sell as a whole. But those manufacturers of the trains, they would like to know what is the pitch between the seats, how far those seats could be apart. Some of them wants 70 centimeters, some of them wants almost 1 meter. And as you can imagine, the behavior of the dummy depends how far it will travel before it hits the seats before. So basically, in front of the dummy. So this virtual testing even allows you to do the parametric study to see what would be the criteria for the head injury if the seats are in different distances from each other. This one cannot be done with any conventional method because it would be really costly. But in the computer, it's possible, and it gives you this huge advantage for which we think that the virtual prototyping, virtual testing is basically beneficiary for the companies. And that's my last slide of this presentation. So if you have any questions, I would be delighted to answer them.
Thank you very much. Very interesting work, Tomasz. And yes, there's a question. So I'm reading it. After the case study, has the company invested in acquiring HPC-related skills, since you as the supercomputing center are developing the models and simulations for the company?
After this project, they opened their own R&D department, and they have their own engineers to use the methodology we developed together. And if I'm informed correctly, I think they even went for design of the aircraft seats, which is another level up. So basically, yes, they used all this methodology and they use it for in-house design team.
Thank you. And there's a follow-up question. Can the maturity model help the company upscale its HPC experience level?
Yes, definitely, because they learned that thanks to the HPC, they could speed up their calculations and they could get the answers in a shorter time, which is very important when you do the optimization, because you don't have to wait for the results for days. You can have it in terms of hours.
Thanks again for the answer. What was the length of the project? You said 2 years, right?
2.5 years, yes.
2.5 years. Yeah, quite good results and yeah, good experience obtained. I believe both for you and the company, of course, for the company. Yeah. Thanks again for the presentation. Then let's continue with the next one. It's again by Tomasz Karasek. Yeah, and this time NCC and European Digital Innovation Hub collaboration model. Yeah, let's hear about it.
Yes, I will first show you a few details about our. Sorry, I have to share my screen. Where is it? I have to, yeah, here. The screen.
Yes.
Okay, so you might heard about this European Digital Innovation Hub initiative. It's funded from the Digital Euro program, the same program, the EuroCC-2 will be funded. And basically, European Digital Innovation Hubs should be the hubs for digitalization of the industry, especially SMEs. Those edicts should be focusing on key enabling technologies, AI, robotics, cybersecurity, and the HPC. In each country, there is several those digital innovation hubs. In the case of the Czech Republic, we have 6 of them, and one of them is focusing.
Sorry, are you changing the slides? Are we in the first slide still?
First.
Okay.
First slide.
Just to make sure that everything's, I mean, changing the slide works or not. Okay. Sorry.
In the case of the HPC, IT for Innovations, or VSB Technical University, is part of the European Digital Innovation Hub, which we created together with the local innovation center, which is Moravian Silesian Innovation Center. And we created a partnership to provide the services to SMEs to basically help them with the digitalization of their companies. Our EDIC is, as far as I know, maybe the smallest one when it comes to the partners, because in many cases there are many partners in each EDIC. In our case, it's 2 legal entities and 3 departments. The one legal entity is the Technical University of Ostrava, and from our university there is a IT for Innovations partner, which has the competencies in the HPC and AI and HPDA, and we have the Faculty of Electrical Engineering and Computer Science, and they are focusing on the processes and the technical means with the Industry 4.0, and they have the Factory 4.0, which could help the companies to digitalize their processes in terms of the robotics and computer vision, etc., etc. And our partners is Moravian Silesian Innovation Center, and they help us with the business development. They do the digital audits of the companies. They help startups with the mentoring services. They provide access to the finance, either from the local government or Czech government, or even from the EU funds, matchmaking with among the companies or companies and the academia to help companies to grow. And basically they take care of our regional innovation ecosystem. So the idea of the EDIC is that the EDIC is located or rooted in the local ecosystem and is specializing in one of the technologies. As I mentioned, in Czech Republic, there is six of them. So the whole Czech Republic is covered by the six EDICs. So the physical infrastructure we could provide to the companies is our supercomputers. Our newest supercomputer, Carolina, is one of the 5 Euro HPC joint undertaking petascale systems, and it could be used for the companies to run the computational cycles. But within the EDIC, we will help them with the domain expertise as well. And the second physical infrastructure, which is in the campus of the university, is the smart factory of our university, and basically is the experimental test beds. You can see the robots, and there are also the CNC machines, etc., etc. So the companies could test their idea first. So our EDIC, in terms of the activities, is divided in several parts. The biggest one is the test before invest, which helps companies to test supercomputer or HPC infrastructure or the Factory 4.0 before they invest sizable amount of the money from their own pockets, so they can test it whether this infrastructure is suitable for their needs, and they can basically safely establish that they don't have to pay for the whole amount, but the EDIC is providing the subsidized prices for them. So basically they have to pay, I don't know, 20% of co-financing, and they can receive the funds from the EDIC. Of course, the others are skills and training, which is almost in any European project. Of course, the marketing, communication and dissemination, innovation ecosystem, and support to find investments. But since we are at the workshop about the HPC, the test before invest is the main focus of this one. So this is our focus, that we will provide not only the hardware, not only the computing cycle, but also the expertise. And it's basically our role, and this role is to provide them the services which they are not familiar with, or they would like to test it. So these are 3 examples how we collaborated with the companies in the past. So, and how this collaboration model between the EuroCC and the EDIC comes into the picture. Basically, the EuroCC, we see it as a part which it's at the beginning. It's the proof of the concept. So if the company comes to us, we first do the proof of the concept, whether the problem they are coming to us is feasible for the HPC, whether it could be solved by the numerical modeling, simulation, AI, etc., and whether the HPC could help there. So if this proof of concept is successful and we will find, yes, it's feasible, it's possible, then there comes the EDIC into the play, because the next phase is the phase which is the commercial one, production runs, etc. So basically, after we prove that this problem is solvable by our experts or experts from the company, or with the mutual collaboration, we will proceed to the EDIC activities, and the EDIC will basically serve as a funding opportunity for those companies. We have reserved about 50,000 euros per case. So basically, these companies could get funding for their smaller cases. It's very similar to this cascade funding like a Fortissimo, which gives up to the 150K per consortium. In this case, we will have the company which will get up to the, I think, 75K per case. They have to co-finance it, I think around 20-25% with their own money, but they can get the services which are basically would cost them more if they have to pay the full price. So basically, this is our vision, how NCC and the EDIC could complement each other. So basically, the activities which cannot be funded by the NCC, because we have all those restrictions, no development, etc., could be passed to the EDIC, because I believe you know the same situation. The company comes to you seeking for the help. You tell them, okay, I can give you, I can work with you on the proof of the concept, but later on, I don't know what to do with you. If you need further services, we have to seek for some other opportunity for the fundings. And the EDIC is that opportunity which could help them, and you can basically build the relationship with this company. You are not sending the company away. You work with this company for the other opportunities, and basically this relationship is created. So these are some more details about the test before invest approach. So it's renting a specific HPC infrastructure. So those companies who are dealing with the AI they will most probably need our compute nodes with the GPUs. Those which are doing classical calculations, they could use non-accelerated nodes, etc., etc. But on the top of that, we can provide the expertise in HPC, HPDA, AI, big data. We could even provide them with the specific commercial software, because we find a way how to include the providers of the commercial softwares into this model. So if some company comes and says, okay, I'm using this specific software, but I never use the HPC licenses, they are too costly, and I don't know whether I will benefit from the HPC. We could basically subsidize the price for those licenses just for the testing, and then the company could decide whether this is the way they would like to go or not. Because if you know, some commercial codes are very expensive if you have to buy the HPC licenses. Some not, but some software are quite costly, and the companies are reluctant to use those HPC licenses because they don't know if this one will benefit to them. So this is the opportunity for the companies who are on the higher maturity level when it comes to the digitalization, but they have the barrier to go towards the HPC because of the price of the licenses. And of course, readiness, skills, and training, that's where we would like to collaborate with the NCC as well, because the NCC again could do some part, but because of the state aid law, we are not able to do too much for the companies when it comes to the training for free. So the EDI could be way how to resolve this problem, so we can organize the courses for the companies which could be subsidized, or we could create the on-demand training for them. And this how we envision our innovation ecosystem. It's not only for the SMEs, it's for all the companies, and it's also for the public organizations, as I already mentioned, the faculty hospital. And basically, we would like to be the center point for those companies when it comes to the HPC, AI, and HPDA. And together with the National Center of Competence, we would like to be very, very strong part of the ecosystem, which will help companies in their journey towards the digitalization. And that's my last slide, with which I would like to conclude my presentation, and I'm ready for your questions.
Thank you for the presentation. The framework that you plan for this collaboration model is very interesting and may shed light for other NCCs, because it's one of the items that is in the plan of Turkish NCC, as I remember in the earlier presentations. Yes, a question comes meanwhile. You mentioned that you provide commercial software for testing. Are there any limitations?
Right now, I can't answer it because I hope not, but the real cases will show whether there will be any limitations. We will see. We have established the modes how we could resolve the many troubles and many issues, mainly legal issues and the other issues. But real life, we'll see whether we have another restrictions there. We hope not, and we hope that we will be able to provide the commercial code for certain period of the time, let's say for 1 week or 1 month, just for the testing. pay-per-use mode with this software, and it will be for this company only for the testing purposes. That's our idea. We don't want to subsidize the software price for a longer period. It's only to test out the HPC infrastructure to see whether it brings benefit to the company or not.
You already answered the second question. How long can they use commercial software for testing? So you plan to 1 week to 1 month, right?
It depends on the case, but it's not for the longer period of the time. It's just for the benchmarking of the infrastructure and testing out.
Okay, thanks. There's one more question, Tomasz. Since there are 6 EDIs in the Czech Republic, are you, as the NCC, planning to train the remaining 5 ones so that they offer HPC-related services regionally?
Yes, yes, we are in the contact with all the EDIs. We had several meetings, and we are planning to use their networks and to train people in those EDIs to be able to, help us with the companies as well. Yes, that's the plan.
Thank you very much. Yes, this model is quite interesting for us to, I mean, possibly we'll be following a similar path. Okay, and then this concludes the presentations by Czech Republic NCC, but we have a very small closing session, a discussion part. Maybe we can, I want to make an overview. I want to hear actually your overviews. Let me ask such a question, just to wrap up what we heard so far in this webinar. For all, I want to direct my question to all companies here and also NCC representatives. Throughout all these experiences, could you summarize the positive and negative sides, and also maybe your suggestions? Maybe you may also refresh your future plans for us as well. Tomasz, are you? Maybe you're tired. Would you like to start, or would you like to rest a little bit? Maybe we can start with Turkish companies, Parabol maybe, or Erste Software. Shall we start with Erste Software?
Okay.
Berkay, yeah, we can hear you. So can you summarize your experiences, positive and negative aspects, your suggestions and future plans on the use of HPC?
For us, we didn't have much negative aspects because what we did was honestly very lightweight work for a cluster. Like, we were just training some neural networks at the end of the day, so there wasn't much negative aspects for us. Maybe if we worked on a larger scale, then we would have more problems in terms of like the data transfer offset for us. But since our testing didn't include that at this stage, I cannot say that for sure. But other than that, for the future, we want to include the cluster usage for our future project as well, because we will still be working in IoT, and I'm sure we will be working with machine learning as well. So there will for sure be a case where we need to train large models and we need to be fast about it. So that's what I like to say.
Thank you, Berkay, for your summary. We wish best of luck and success for the rest of the efforts.
Thank you.
And shall we turn to Parabol? Abdülkadir and maybe Cevat, would you like to say something on your future plans, on your experience and your future plans? maybe they are not ready yet. Then maybe we can turn them again. May I ask the same question to NCC representatives, Turkish NCC representatives? How is your experience as the NCC side on these use cases, on these industrial relations? Maybe Kerem, I see Kerem turned the video on. So would you like to say something?
Okay, it's been mostly positive for us too. We have learned a lot, and it's been a nice opportunity generalizing some of the infrastructure and academic expertise we provided in the Truba documentation. I hope they are helpful for the other industrial users and the academicians, academic researchers as well. I summarized some of our plans in my presentation for the next phase. And I have a question for the SMEs, actually. Can I ask a question?
Sure, if they're ready to answer, sure.
Okay, maybe Berkay is here and Mikhail also. What would you be motivated to upscale your maturity level, for example, from HPC user to HPC champion and HPC champion to innovator? Or what are the requirements for the maturity model to be successful for upscaling your SME? What would incentivize you to get to the next level and use the, for example, the European supercomputers in a more productive way?
Yeah, so kind of how can we improve your motivation to extend your level, maturity level? Is it correct if I interpret your question that way, Kerem?
Yes, it is correct.
So any volunteer to answer? Berkay, either from Erste or from Parabol or from Czech Republic use cases. I think it was kind of a hard question. So possibly everybody wants to improve in that sense, but it has a cost. Maybe how to alleviate this cost. This may be a question.
Yes.
A help on that side could be needed. This is what I imagine, kind of as an outsider. I'm not from the industry, but this is a very nice question, and yeah, maybe we can keep it aside to maybe distribute, to ask again in other occasions, and maybe in an offline or in another through emails or other communications.
Maybe the white paper can also clarify more points about the maturity model.
Yes, sure. More details and more results, yeah, could be present there. Okay, thanks. Again, there's a question to NCC Czech Republic. How do they convince SMEs to use HPC in their work? To Tomasz and Michal. Yes.
We have to convince them that there is an added value for them. And we have to convince them showing this on their own problems, because otherwise they are reluctant to use it. So this is quite, in my opinion, good added value of the EuroCC project, that we could spend our effort on those proof of concept or those activities which could convince companies that it makes sense for them.
Thank you. And the same question goes to EuroCC-Turkey too. So how do you convince SMEs?
Okay, maybe I can answer. We convince them by we acquire most of the SMEs using our academy industry academy. We use the academic partners, so they have existing relationships with the industrial users. We also have another channel, the TEDEP channel. TEDEP is the official funding directorate in Turkey for the industrial research projects. So we get in contact with them directly with a phone call and tell them you can also use the HPC infrastructure in your work, and it's for free basically. And also a academic expert from the linked third-party universities, Sabancı University, Middle East Technical University, and Istanbul Technical University can help you during this case study. So this free, valuable mentorship opportunity, together with the free infrastructure access, the resource access, I believe helps in convincing them.
Thanks, Kerem, for the answer. I have a personal experience. I took part in this relationship industry, I mean, the HPC use cases, in one of the use cases. And my observation is that the companies really appreciate and value this effort, these supporting use cases, providing infrastructure, enabling them to use this infrastructure in their for their own project or some part of their project. But my observation was that they sometimes cannot allocate person to do it. So in their work life, I believe, yeah, they have to keep up with, and there's competition there. This is one of the reasons. I mean, time and person to allocate is one of the problems, which I don't know the answer, how to solve it. But on the support side, I believe they really appreciate. I mean, this is my observation on a small scale, only one case. There's another question. Which problem have you as NCCs encountered most in your industry collaborations? So both Turkey and Czech Republic side. Maybe, yeah, we can start with Kerem. Would you like to say something?
Okay, I guess it's the one you mentioned. They face difficulties allocating person months to gain the HPC related skills and continue using the HPC infrastructure sustainably. And as a solution, we had one-on-one meetings with Castiel about the industrial collaborations, and one of the solutions is the direct funding mechanism to the SMEs for HPC, like FA for EuroHPC was really nice. I offered this solution to Marie-Françoise in that one-on-one meeting. So I believe that can be one of the solutions. We also initiated a collaboration with the Mind for Machines, which directly funds the technology provider SME. So creating these other type of collaborations with the other European projects might also solve this problem.
Yeah, developing and realizing additional mechanisms.
Yes.
Augmenting mechanisms, maybe. I mean, as Tomasz also mentioned in this collaboration model, which also has a funding part as well. So I'll lastly turn to Tomasz again. Would you like to say a few things as the final things to or an overview to wrap up and to close the meeting?
Yeah, I just would like to thank you for the opportunity to present our work at the workshop. I believe it's third or fourth occasion we collaborated together with the Turkish NCC, and I hope that this fruitful collaboration will continue in the second phase of the EuroCC project. Thank you very much.
Thank you very much for joining, for presenting your use cases and your efforts. And I see Cevat, would you like to say something maybe on behalf of Parabol?
In fact, I mean, on behalf of me and on behalf of Parabol, I would like to thank you for the organization, in fact. And also having those case studies, in fact, it's a great opportunity for the SMEs, I believe. There exists Parabol and some similar companies, I believe, with such, some tasks, in fact, that need HPC resources and some new style of solutions they can achieve and they can benefit from. So still, Parabol also has some more, in fact, on the same platform. I mean, the public transportation analysis platform and in some other projects, I guess, and I hope they will also make use of such future, some other opportunities. So thank you.
Thank you very much. I'd like to thank to all presenters, all attendees, particularly our guests from Czech Republic. And I hope to meet you all in another joint meeting. See you next time.
See you next time. Bye-bye.
Thank you.
Bye-bye.
Thank you. Goodbye.
Thank you. Goodbye.